conference. Thank you so much for coming here. My name is Leo, and this is Mackenzie. I'm the CEO of Invo Station, and Mackenzie is the CEO of Invo Station. We're here to show with you and share with you basically two products that we're releasing right now. And we're very proud of this work. It took quite a bit of time and work, especially the last 3 months. I personally slept in the warehouse for about almost 2 months to get it done. So it's been very intense the past few weeks. So we are basically an electric vehicle that can also fly, referred in our industry as an eVTOL, which is electric vertical takeoff and landing vehicle. All it means is electric vehicle that can take off vertically and land vertically, so it doesn't require a runway basically. So this is what we make. We make the whole vehicle, we make the electronics of the vehicle, the autonomy system of the vehicle. We have some parts and pieces that we contract, but pretty much we try to make everything in-house. So we're also part of NVIDIA Inception program, which means we're NVIDIA powerhouse from software and hardware, and then our autonomy infrastructure is NVIDIA infrastructure as well. So everything runs on GPU, just because we do a lot of basically graphic processing and a lot of some application related to autonomy, a lot of cameras and videos and all that. So this is me and this is Mackenzie. We're located in California. We have our engineering HQ in San Francisco, and then we have the assembly facility in Anaheim Hills in California. These are the addresses on the right. We also have our contact information on the right side. Feel free to take a screenshot, and we'll make sure you get a copy of our contacts. So Invo Station started in 2021 as a concept. And between 2021 and 2022, we did a lot of prototypes. 2022 became an incorporation in California. And then after that, we've been doing a lot of work. We did a lot of conferences with NASA JPL, with NVIDIA, with TechCrunch. And we started basically depending on NVIDIA GPUs to run our autonomy. And then right around early 2023, we started building the full-scale vehicle. So we switched from a prototype, which is about a few inches in size, into a full-scale vehicle, which is 16 feet wide vehicle. So the vehicle pretty much will fill this whole room almost. So we have actually 3 designs, and I'll show you more information. The vehicle we're releasing first is the luxury vehicle. This is the large vehicle, the one that's bigger than all other vehicles. It's designed, it carries 3 passengers, and it's designed for transportation between places, just like as a personal aircraft or flying vehicle. And we pretty much finished our first vehicle ever at pretty much the last day of 2024. So right before the new year, we built our first pre-production vehicle. And what we're doing today is we're gonna open the pre-orders for those vehicles. And the vehicles will be delivered 2 years after that. And I'll tell you more details about that. And we're gonna be in Saudi Arabia in February at LEAP. We might bring the vehicle to LEAP, depends on how the logistics works, just because we don't have a lot of time till February, so we'll see. So what we do different than drones or like larger eVTOLs or aircraft that are vertically take off is we changed the motor, the way the motor works basically. So before starting this, what I wanted to build is I wanted to build a small, cheap aircraft that people can use for personal transportation, but I want to make it cheap enough so everybody can use it. Otherwise, if you really want to scale them and have like a major environmental impact, which is the drive of everything we do here, you have to do it at speed and scale. You have to drop the price low enough so anyone can afford to buy it, and then you'll see a lot of them in the skies. Otherwise, it becomes just luxury for the 1% of population. And to do so, I wasn't sure if people are interested in buying these vehicles. So what I did is I went to multiple conferences, and we ran a survey while we were expoing our idea as a startup. And one of the questions that's really started our company is we asked people, how do you feel about riding in vehicles like these? And we have pictures. And we found that 90% of people are terrified of the propellers, because in these eVTOLs, you're getting in and out of vehicle with propellers that's going at very high speed, several thousands. The RPM is very high on these motors, and it scares people. So we realized this is a problem. We can't make something everybody will buy like a regular car if people are scared of it. We can't make very niche vehicle. We really want to expand it to everyone. I wanted a vehicle where my grandma feels comfortable riding in without having to know a lot about tech, and so we made everything very simple and very. So what we did is we reinvented that motor and we created a contained motor, which basically doesn't have an exposed propeller, and then we put those motors inside the vehicle rather than having them exposed on the outside. And I'll show you a little bit more details on that. So this is the shape of the vehicle. The vehicle is round, and then we have 12 motors that goes inside the vehicle, and they go in the gap between the external body and the cabin on the inside. So there's that gap. This is where all the motors goes, and this is also where the battery goes, the battery pack that powers this vehicle. And what that does, first, it's basically hides the propellers. The passengers will not even see them. And then when it's like when you ride your car, if you can see the motor under your feet, it'll probably scare you too. Same for engines, non-electric motors. If you see the gearbox under you, it'll probably scare you unless you like that kind of stuff. And pretty much, so this is kind of like the solution that we came up with. And we took that motor, we tested it, and we wanted to see how can we make it practical. And the best design that we tested is having a lot of motors in close proximity of each other. And then we ended up with 12 motors. And those 12 motors basically operate. I'll show you another photo how they take off and land, but basically it requires a round vehicle shape so they can distribute, the control system can distribute that motion very smoothly. And the inspiration of that shape came from an invention for Leonardo da Vinci called the armored car. So that armored car was designed basically as a round vehicle. It's basically like a car, and the reason why it was round because he placed guns on the surrounding of that vehicle. And in our design, instead of guns, we have those motors that require that motion, round shape motion. And then we kind of cleared up things for aerodynamics. So we smoothed out the top, we smoothed out some of the corners, we made the bottom also smoother. And it's ended up looking more like this. So we have 3 designs of 3 vehicles. And 2 of these vehicles is not released yet. So that's the first time you see this. The vehicle V0 Invo Moon, this is the vehicle that we're revealing right now. This is our first vehicle, it's a luxury vehicle. This vehicle can take 3 passengers on a 300-mile range of full charge based on an EPA estimates. And then it has a control system that allows a 360 motion in all directions instantaneously. The price that we're revealing this vehicle at is $350K. So this is our luxury vehicle. And just to give you an idea in perspective to this market, eVTOLs goes, the minimum price you can buy any vehicle in this market is about $1.7 billion. So we're way lower than anything that exists right now. The average price is $10 to $20 million for those kind of vehicles. And the reason we're able to make it and still become profitable is we really designed everything in this from day one for mass production. So we got rid of all the processes that are very labor intense, that takes a lot of hours of preparation, a lot of manual labor, and so we got rid of all carbon fiber materials, we replaced it with aluminum material. We designed the aluminum in a way that can be produced very fast and very cheaply. And the body of the whole vehicle, just the metal exterior body, takes 2 minutes to make in our automated production line. So it's very efficient. It can be done a lot cheaper than anything that exists right now. So, and we're pretty much looking at this vehicle from automotive perspective rather than from aerospace perspective. In aerospace, most of aerospace applications came from military perspective, where you have hundreds of millions of funding and you don't care about how much things cost. In automotive, you have to make it very cheap, very efficient, and safe at the same time, so people can be able to afford to buy it. And that's kind of our goal. Our mission is to make a very cheap vehicle accessible for everyone. The other 2 vehicles, they're designed yet, they're not tested yet. We haven't, it's pretty much just a design, and we'll be producing those later on. So V4 Invo Mars is the family vehicle. We'll have 6 passengers and 250-mile range. then V3, this is kind of the dream vehicle. This one is a very compact vehicle. It's designed to go in crowded downtowns. And we're pretty much the only company that can fly those in crowded cities. One of the main reasons is having the motor inside the vehicle, and having contained motor makes it very safe to fly near buildings. The aero vibrations is a lot lower than anything that exists right now. And on top of that, we're silent, we're completely silent. While in most of other basically drone-like vehicles, each motor has a noise level of 80 to 85 decibel, so they're extremely loud. You have to wear ear protection if they fly by you, if they land in the city or anywhere that's populated, so they're not practical to be used at large scale. And our mission really to make vehicles that are used for large scale so everybody can benefit from it. Now the goal for that V3 vehicle to be sold at pretty much similar to a regular car price. So we want to drop it down to $60,000 and then we'll see how it goes by then. This is the dream, this is the goal, and this is really what started this whole company, that vehicle specifically. In the meantime, we'll be making a lot of vehicles. We have about 12 vehicles that we'll release later for different applications, but this is what we're starting with right now. So Invo Moon will look more like this. And then basically the top and the bottom are clear. This is where our autonomy system sits. And the vehicle is completely autonomous. It operates, I'll share later more information about the autonomy, but you go inside the vehicle, you have a screen, you type your address, it will do three things: calculate the best route to take off, the best route to your destination, and then the best route to land. Now we are just opening the pre-order for this, so now you'll be able to pre-order the vehicle. That pre-order will go in our backlog and will basically will be delivered 2 years after that. So the estimated delivery is 2027 for this vehicle, and this is our goal basically. It could be delayed slightly more than that later. You can't anticipate 100% on that just based on production and fund raising and all that. But this QR code will take you to pre-order, or you can just type InvoStation/pre-order. You'll see it on the top navigation bar, and then basically it'll prompt you to put a small down payment that goes into your full purchase later to reserve your spot. The second big thing that we're revealing right now is our autonomy system. So our autonomy system was designed mainly for our vehicles, and it's basically an NVIDIA-powered autonomy system that uses 16 cameras distributed between the top dome and the bottom dome. So you'll see here, there's 16 cameras on the top, 16 on the bottom, and then we have LiDAR sensors. What that does is create a full vision in a spherical way, like you see here. The green is the top coverage, and then the bottom is, the blue is the bottom coverage, and creates basically a full spherical coverage of the entire vehicle so it can see everything around it. And unlike cars, we need more cameras than cars do, just because we take off vertically. So we need to look up when we take off, and then we land, we need to look down. So we have to have full camera coverage for that. And then we cover all, we don't have any dead angle or dead area for vision where we can't see. We have to see everything. And we have to do that while we're going at, our maximum speed is 250 miles per hour. So you have to keep that resolution at that speed. So this is kind of a tough challenge on its own. And on top of that, we have proximity sensors for safety, and we also have our proprietary vehicle-to-vehicle sensor. So that's pretty much, what Invo Dome is. And I'm going to show you a quick video, shows how, so the FAA is the regulator in this space, and they created what they call FAA Blueprint. They said if we come to a situation where we have hundreds of thousands of vehicles flying in the skies at the same time, how would we regulate that? So they created a document. We took that document, we made it a software in our computer, and then we created those scenarios in the brain of the code algorithm of that software. So now we operate based on that, and then we visualize that so you can see how it works. So let me show you that.
Station is a revolutionary eVTOL system that simplifies urban air travel. Invo Station allows you to fly using 3 vertical lanes, each at a specific height, connecting major destinations. The speed limit varies across the lanes, with the lowest lane having the slowest speed and the highest lane having the fastest speed. To take off and land, Invo Stations operate vertically. They start with a 90-degree vertical takeoff to join the desired lane and can switch lanes to achieve the desired speed. To land, an Invo Station must be in the lowest speed lane, so it may have to change lanes if it is in a higher lane. To accommodate multiple Invo Stations moving in the same direction and at the same speed, each vertical lane can have 3 horizontal lanes. Additionally, there are 3 sets of vertical lanes moving in the opposite direction, maintaining a safe distance from the first set of lanes. This design allows for increased scalability, enabling more Invo Stations to fly between congested cities like San Francisco or LA. Autonomy plays a key role, as it allows multiple Invo Stations to fly together in sync. Each station has visibility of the others and can communicate with those within range. Invo Station is designed for personal transportation, providing a convenient and efficient means of travel. Invo Station, sky is the limit. Invo Station is a
So this is pretty much how the autonomy system operates. This is basically visualization of that code when the vehicle operates and flies. And one thing to kind of explain how that motion happens basically. So we have, like I said, we have 12 motors goes inside the cabin of the vehicle. We have an air inlet on the top. You see there's a gap here. That air inlet will allow the air to go through the vehicle and then go through the body of the vehicle where the motors operate. And then we'll exit from the bottom where that other dome is. And then we created air channels inside the body of the vehicle that basically allow that very precise control of the takeoff, the landing, the maneuvering, and then say the vehicle wanna go a certain direction. What we do, we divided the motors into multiple control groups. And those control groups will trigger, so we'll change the frequency in the amplitude of a certain group, and we'll tilt and go that direction, same for any other direction. What's unique with the 360 motion is, for the aircraft to fly, instead of having to, like a helicopter or eVTOL, go make a very wide turn to go to a certain direction, we just trigger a different group and we'll just tilt instantaneously to any direction we need to go. Makes it faster, more efficient, and more comfortable for passengers. That being said, the vehicle doesn't have a front and back. It's just, it's 360, and the passengers were all sitting in the middle. There are 3 seats facing the center. This table that comes out. This vehicle has a luxury package, which is different than other vehicles, so it has a lot of luxury features for the seats, it has like a cooler, a coffee machine, ice maker, things from that nature. And it's very, like when you go inside the vehicle, it's huge, it's very big. And then we put a payload of 600 pounds, so 3 passengers, about 200 pounds per passenger, for basically the weight of the passengers for the vehicle to fly within the range of 300 miles. So say you have larger weight, people have more packages or more luggage, the range will decrease to a limit if it's not safe to fly, if it's overloaded, like when you go on an airline and they tell you the aircraft overloaded, we have to unload some suitcases. So it'll automatically tell you we can't fly safely, we need to decrease that load. There's a lot of safety features that tells you, since this is electric, if you put a destination, you want to go somewhere, it'll tell you you need to stop at this place to charge your vehicle before you continue, otherwise it's not safe to fly. We'll give you recommendation to where to stop, and it will not take off until you select a safe route that allows you to arrive with a certain charge that's safe to take off. One of the things that this vehicle has and nothing else has is, since our propellers are hidden, if a bird flew into it, there's no way for the bird to break your propeller. So it's safer than anything that flies right now. Even larger jets, like recently there was an incident where Fokker bird hit an engine for Boeing and it fell down because of that. This is very safe. And then on top of that, our vehicle is designed to take off and land safely with 4 out of the 12 motors functional. So if we lose 8 out of the 12, we can still land safely and make sure that the passengers are safe. So it's pretty much one of the safest vehicles that exists right now. And this whole autonomy system, like I said, powered by NVIDIA. We have basically a direct distribution model where people can order the vehicle online and we'll ship them directly from our production line to the customer, so there's no dealers in between. Most of aircrafts, they usually have people that sells them and make that connection between corporation and manufacturers, or yeah. So, and then our production lines. This is a photo of our assembly facility. Basically, we can produce 1,000 body of vehicle a day, and the top and bottom domes, which you don't see in this photo, they're clear domes. We can make 20 a day right now within the size of our facility. Our autonomy system, we work with companies that make the cameras and the lidars. They make tons of those. They can make 330,000 a day, so like it's way more than we can consume. And we could assemble 20 vehicles per day within our facilities right now. In the future, once we have larger orders, we'll expand our facilities so we can accommodate more vehicle orders. We've raised $5 million when we started this to come into fully functional vehicle. We pretty much spent that. Right now we're raising new round of $49 million, and that will go into a lot of different things, mainly building the AI infrastructure. So basically for creating and testing, thousands of simulated flight scenarios, we use AI infrastructure that's also powered by NVIDIA. And that's basically requires servers with GPUs that are very high speed. And this is one part where we're spending that. And then the other part is the FAA certification of the vehicle. That will take about 2 years, usually take 1 year, we estimate 2 years for the vehicle to get the certification so it can basically fly legally. And then our valuation is $700 million right now. We're giving that 49 and 7% of the shares of the company. And this is pretty much what I wanted to share today, and the rest will be just open for questions.
You described the interior with the people sitting at the center.
Yeah.
I saw your aluminum domes. I did not see a way for people to get in and out of the vehicle.
Yeah. So basically, if you see the other photo, let me open it. Makes it easier to describe. So basically, one of these slides down, and then inside of it there's steps that folds out. Then you can step in and out. And then also, one thing I didn't mention is when the vehicle goes to the ground, there's 3 wheels that retract. So there's opening for 3 wheels to sit on the ground basically and stay still. Otherwise, you have to keep the motors running the whole time you're on the ground. And then the wheels has wheel hubs. So basically, you can drive it on the ground. If you want to take it, for example, you're on the road and you want to take off somewhere, to find the safest route to take off, you'll drive it until you find that route to take off. To avoid like power distribution lines or anything else, you can drive it like that. So that's how it works.
What is the projected weight of this? What would be the weight of the battery pack?
So the whole vehicle is 2,500 pounds, and what we did is we basically redesigned the battery pack. So that's very important in pretty much everything that exists right now. The battery cell technology is really not designed for flying vehicles. In flight applications, you need the lightest weight possible. And what we did something unique. So I used to work for Tesla. I built the production lines for the Cybertruck, and I built the battery technology for 680 that goes in the Cybertruck. That's a very unique technology. So I did something very similar in this vehicle. What I did was the battery pack, I got rid of the epoxy resin that goes between the cells, which is basically the heaviest part, and then the aluminum chassis that holds it, because in cars, you want to keep the weight on the ground. It's part of the structural pack, and also when you accelerate, you don't want the car to take off and flip. So you want to make it heavy in the bottom and keep it on the ground. And our application is different. So to compensate for the epoxy losses and still make it safe to cool down, since the body is made out of aluminum, we basically created channels in the body to hold the cells. So the strings of the batteries goes through those channels and cool down to the body. So that way you have higher thermal efficiency than regular packs, just because there's aluminum everywhere, and aluminum is very good in cooling. So that's pretty much how we approach that battery problem. Our motors are very light. The main weight problem comes in the battery. In the future, we anticipate to design the cells in a way that we make our own cells, but that's going to take a long time. And at this moment, we are using existing cells. We're just reconfiguring them to be more efficient and lighter, as light as possible. There was a question?
Yeah, excuse me. I have two questions.
Go ahead.
First is, I think it's very obvious. It looks like a classic flying saucer, like a UFO. Did you ever think about the marketing implications of this?
Yeah, so basically, earlier, I don't know if you might have missed this one. So the design when we started this was inspired by a patent invention, sorry, for Leonardo da Vinci. And then when we smoothed it out for aerodynamic, it became look like a flying saucer.
Yeah.
And we embraced it very well. So we, like for example, the top dome in the initial design was a metallic dome, and then we had cameras and lidars fixed. So we had to use static lidar to basically keep that metallic cool shape. And then for safety, the FAA required you to have windows. So we had to basically replace it with a clear aerospace grade, basically clear dome instead of metallic dome. In the future, I think we'll be at a point where we'll also make it fully metallic to keep that like cool look of the whole body all metallic that has authentic, that cool shape of it. But it still look very nice even with the clear top and bottom.
Yeah. And my other question is that you were talking about this vehicle being like tens of thousands of these flying at the same time, all lanes and stuff. So how do you plan to solve the landing? So like if you have tens of thousands of these vehicles in a city, like you have to land them somewhere. These are quite big, so
Yeah.
how does that work?
And what's unique in our vehicle that we're the only vehicle that can actually land on street and take off from street. We don't require helipad or airports, or because the technology itself is very silent, it's quiet, it doesn't cause like basically a tornado anytime it takes off or lands. And so the way we're designing the autonomy system, it's designed to scale as much as we scale our vehicles. So in software and simulation, we can simulate, million vehicle flying, and we can run the AI computer to do that simulation for hours and hours and hours, and simulate, massive number of scenarios that can happen. You can simulate birds, things flying into each other, all that stuff. In real life, we're gonna sell them gradually. This is one of the reasons we started with a luxury vehicle, the more expensive vehicle, because we don't want to have tons of vehicles flying at once, because our autonomy system is still getting developed, and we'll never have full autonomy until we have a lot of vehicles flying and until everybody else is autonomous. So that's why the product here, Invo Dome, that autonomy product, we actually made a modular autonomy system that we will sell to other aircrafts, and they can install it on their vehicle and make their vehicle autonomous too. Because we believe if we really want to achieve full autonomy, everyone has to be autonomous. So that's kind of one of the reasons we came up with this product, and we made it available for people to purchase for their own vehicles, for helicopters or eVTOLs and things from that nature. So it's gonna evolve gradually. The more vehicles we sell, the more vehicles start coming out and flying in the skies. And I don't know if you know, but San Francisco is gonna have one of the eVTOL companies flying this year. So this is not something, futuristic. There's China already having EHang flying all over the place. There's a few other parts of the world, like Saudi Arabia. They bought 200 Joby eVTOLs. Joby is another American manufacturer. And it's happening right now. Toyota has a partnership with one of the American eVTOLs to also fly in Japan. This is happening, today. It's not going to be in the future. And in a few months, you'll see Joby flying in San Francisco. So if you go to San Francisco, I personally, pivotal Joby Archer, I personally seen and then went inside all.
Yeah, thank you.
Yeah, no problem. Go ahead. Yeah, go ahead.
So tell me more about your software business. So because you mentioned about the use or the sold to the VTOL OEMs. So let me have more information.
The software in regard to autonomy or in regard to rideshare. So I'll give you both. So autonomy, for example, the software and the hardware is pretty much all NVIDIA tools. So we created our own. There's a lot of already created infrastructure that's used for cars on the road. So I don't know if you've been into Waymo, for example. They're the best example of fully autonomous vehicles. There's no driver. You can drive in San Francisco, LA, Austin. And we use similar infrastructure. And we found out that Waymo has a lot less data to handle than we have because they have less cameras. Their cameras have a lower resolution. Our cameras, all of the cameras are 4K resolution at this point, and we might even expand it to higher than 4K in the future. So it's a lot more complex computing. The software itself is a lot more complex. And then the other part is we also have a rideshare software that we will offer. So for example, for people, if they want to have their own Waymo, they'll buy the vehicle, and then they'll use our software where people can reserve their vehicle and use it like a taxi or like an Uber. And then they'll get paid while they're sitting at home, and we'll get paid. We'll both share that profit, so we're not taking the driver off the equation. And then basically the vehicle will go from their home, take people around, and then when it's time to charge, we'll go back home. The owner will clean it, charge it, do all that stuff, and then that's another business model. I don't know if that covers the software question you're asking, because there's a lot of software that goes in there.
Okay, so my point is you already sold to the digital OEMs. So who is the buyer or which company is using your software?
So for autonomy?
See the last two bottom lines sold to digital OEMs.
Yeah, so this is just released right now, so we haven't sold it to anyone yet, any eVTOL company yet, and we're literally just revealing this now.
Okay.
Yeah. So we'll be reaching out to all eVTOL companies, helicopter companies, and we'll share with them the benefits they can get from this, how we'll make their vehicle more desirable for people to buy and all that. Yeah.
Question. So you said that people fear propellers, and
Right.
you said it's hidden. Now, could you explain how it's hidden? And then it's like, is that not the propeller? It's just a motor, and how does it work
Yeah.
without contacting the air?
Yeah, so there's already air coming in and out, so there's air contact still. I'll explain how, may have not done a good job explaining it earlier. But basically, so this is the chassis, right? And then inside the vehicle, there's a cabin where you sit. In between, there's a gap where you see that sharp angle. That gap can't be used for people because it's very sharp. So that gap is pretty much where the motor sits inside. And then the bottom part, so under this sheet, you'll see the motors. There's 12 of them going in a circle. And then under this part, this is where the belly pack sits. Yeah. And then the aerodynamic, there's still air contact. So you have air comes here, filters out through gaps. So the gap between the dome and the edge here, this is where the air enters.
Oh, yeah.
And then it exits from the bottom when it's taken off. It does the other way when it lands.